This is no ordinary battery facility. Inside are piles of used and faulty EV batteries, many of which will function again, re-entering electric vehicles after Spears New Technology rebuilds the ones they can and salvages critical minerals from the rest.
It's fantastic that you can drive an electric vehicle knowing that at the end of the life of that battery pack, the ingredients will be reused in a new battery pack and a new electric car. And that we really want to play a role in.
Dozens of electric vehicles are scheduled to debut in 2024, and over 300 million EVs are expected to be on the world's roads by 2030. Tesla, Volvo, and GM are just a few companies leading the way towards electrification. But with any new technology comes new problems to tackle.
If you're going to call yourself a green company, you don't want your batteries piling up in junkyards.
The volume of recycling is hotly debated right now. There's been billions and billions of dollars of venture capital that's gone into it.
The degradation of an EV battery pack is one of the biggest questions of the industry. Every battery will reach end of life. And it's important that these end-of-life packs are recycled so they don't end up where they don't belong.
CNBC explores how used batteries will play a role in the future of electrification and what one Oklahoma company is doing to help with the millions of used battery packs with nowhere else to go. The American EV market is small in comparison to operations in China and Europe. In 2021, the U.S. accounted for less than 10% of new global EV registrations, while China accounted for 50% and Europe came in at 35%. When it comes to EV batteries, China accounts for over 70% of global production capacity, leaving the U.S. heavily dependent on imports from battery minerals.
The life cycle of an EV battery really starts when minerals are extracted from the earth, and those minerals are used to produce an EV battery cell.
The critical minerals that go into EV batteries include lithium, cobalt, manganese, nickel, and graphite.
It has been clear since 2014 that China had a plan to lock up the bulk of the world's production of battery minerals. The world's largest battery company is now in China.
Now under President Biden's Inflation Reduction Act, EV manufacturers can qualify for a tax credit if 40% of its critical battery minerals are sourced domestically or with a free trade partner like Canada by 2024.
This is industrial policy of a sort that we have not seen in this country for a very, very long time. In theory, a certain percentage of the battery minerals has to come from a small list of countries. The battery, the cell, the processing, all of that has to be done onshore, and the car has to be built in the U.S.
Sourcing minerals domestically is necessary to keep up with new regulations. But opening mines in the U.S. has been met with opposition from local communities concerned about environmental and health hazards. Recycling and reusing used battery packs is one possible long-term solution.
It's very early stages. We're kind of talking about a business that is just forming now and won't really hit its stride, at least in the United States or North America, till like 2030, because that's when we'll start to see more and more EVs get to end of life and more battery packs.
Both public and private commitments suggest that EV production will increase in the U.S., which means more American companies are likely to enter this space of EV battery manufacturing and recycling too. Companies like Redwood Materials, Li-Cycle, and American Battery Technology have already developed processes to recycle lithium-ion batteries.
We're building the infrastructure for something we expect to exist in several years that isn't really at a big scale yet. If they can get the cost comparable to newly mined materials, the demand will be very significant because nobody really wants to be mining cobalt and nickel more than they have to.
There are a number of smaller players now who do this for hybrid batteries. And I fully expect them to expand into battery electric vehicle batteries. They're correspondingly more valuable, and you can probably make more money servicing a dead battery electric vehicle than a dead hybrid.
Repairing, remanufacturing, repurposing, and recycling of EV batteries. That's what's happening here in Oklahoma City at Spears New Technologies.
The number of battery packs we have here are in the hundreds. We make sure that they are clean, and then they go on the racks to be processed, taking them apart, testing them, building them back together, make sure that they are as good or better than what they replace. And then they go back on the rack again, waiting for a dealer to need one of these, and then we send them out.
Dirk Spears is the founder and CEO of Spears New Technologies. His company specializes in the lifecycle management of EV battery packs by extending its first life and reducing the need to mine critical minerals.
I've been in batteries for almost 15 years now, hence my gray hair. We believe that the world is going electric, and we wanted to extend the economic life of those battery packs and help the OEMs with their life cycle management. And we do that all under one roof, on the one campus.
Spears New Technologies, or S&T, was founded in 2014 with just 2 employees. In 2021, it was acquired by Cox Automotive, a subsidiary of Atlanta-based media conglomerate Cox Enterprises, which has other automotive brands like AutoTrader and Kelley Blue Book. The company now has over 400 employees and offers what it calls a one-stop solution for used and faulty EV batteries.
We are like a diner of battery services. So you can come to us for a cup of coffee, but if you want to have a steak or a cup of soup or apple pie, we serve all these things.
S&T receives batteries directly from the dealership or original equipment manufacturer, for example, Toyota or Porsche. It then puts these batteries through its diagnosis system named Alfred. Alfred assesses the health of the battery pack to determine whether it eventually can go back into a vehicle. To get there, it can be repaired to operational conditions, remanufactured to original factory standards, or refurbished and upgraded to current factory standards. Otherwise, S&T can repurpose it for a second life, usually energy storage. And if the pack is truly at its end of life, S&T will recycle it as a last resort.
The result of our mechanical shredding process concludes with byproducts that are captured in these large super sacks here. These super sacks contain the byproducts of plastics, aluminum and copper foils, as well as black mass. And that black mass consists of critical minerals, cobalt, magnesium, aluminum, copper, graphite, and of course, lithium.
In addition to its headquarters in Oklahoma City, S&T has facilities in Las Vegas and Detroit, with plans to expand to the East Coast. It also has operations abroad in the Netherlands and plans to open in the UK soon. But being centrally located in the US is key for its business model.
We need to be where our customers are. Being bang in the middle of the country helps. We can reach either coast between 2 and 3 days. We can ship by air. So if it really needed to be, we can have a battery pack the next morning by 10 o'clock.
S&T does not work direct to consumer. An EV owner brings their battery pack to a dealership, which then sends it to S&T to be serviced. That dealership swaps out the customer's battery with an operational one already in stock. If none are in stock, S&T will send the pack from its storage. Meanwhile, S&T works on the customer's battery, then stores it to be sent out later. S&T also works with battery manufacturers and car makers, which can send faulty batteries to be repaired. The company says its facilities total over 800,000 square feet of production space, and 500,000 of those are for battery storage. It wouldn't disclose the number of battery packs it's capable of storing, but says it handles on average 15,000 battery packs and modules per month.
We get anything from, say, 50 to 100 battery packs per day. 80-90% can be refurbished and that it's good enough to go back into a vehicle. Recycling is maybe 5 to 10%, and the rest is repurposing, second life. But those numbers will fluctuate.
Repurposed battery packs can be reused in non-vehicle applications such as energy storage for solar panels and power grids.
Because the industry is so new, I think we're squarely focused on providing end-to-end lifecycle management for every battery that comes to our operation.
Since its inception, S&T says it's serviced more than 240,000 packs, and more than 50,000 have been repaired, refurbished, or remanufactured. It's recycled 3,000 packs.
If you look at the EV market, and if you take Tesla out, we probably have 60, 65, 70% of that market, of the non-Tesla electric vehicle OEMs. So that's a lot. GM, Ford, Stellantis, Porsche, Volkswagen, Nissan, Toyota, Volvo. We keep adding to the list.
And when asked why they don't work with one of the most recognizable brands in the EV industry?
No, they always do they like to do their own stuff. They're a little bit like Apple. And also and maybe this is not politically correct, their payment terms are like really bad. So I think the industry owes a lot to Tesla. They made electrification sexy.
When I think about the future of EV battery recycling specifically, I see it as an increasingly competitive space, but at the same time there's a bit of a mismatch of maybe more supply and capacity around EV battery recycling than demand, because we're just riding this first wave of electric vehicles who could be on the road for 10 plus years.
The lifetime for an EV battery is estimated to be 12 to 15 years in moderate climates. However, the estimated reuse lifetime of an EV battery can range anywhere from 5 to 30 years. By 2050, the demand for graphite, lithium, and cobalt is expected to increase by 500%. But extending the life of an EV battery can reduce the need for critical minerals. So could battery refurbishment become a big business, and how profitable is it right now?
A couple of years ago, there was a cost associated with recycling a lithium-ion battery pack. Now it is a positive. If you give me a lithium-ion battery pack, I probably will give you money back for it. And that's the beauty of it. The intrinsic value of that battery pack is higher than the cost of recycling.
The world has a finite amount of minerals necessary for EV batteries. It's hard not to speculate. Could indefinite recycling and reuse be the future?
Absolutely. The circular economy is happening. It's happening right now. It's happening here in Oklahoma City. Why would you get cobalt from Africa or lithium from South America if you can get it here in Oklahoma City? Critical minerals will always be reused. And it's already happening, but the volume is still small, but it will get bigger and bigger.
I think we will be mining metals for the balance of my lifetime, but indeed, the hope is as batteries get more powerful, smaller, lighter, and cheaper, with luck, we will need fewer metals.
We could get to the point where maybe a significant majority of battery materials are recycled from old batteries, but we need to hit critical mass on EV penetration first. There just aren't enough EVs out there yet, but maybe 10 or 20 years from now there could be.
Some critics believe the EV battery recycling business could be booming too quickly, and that the current capacity outpaces demand for this service, at a time when most EV batteries have yet to reach the end of life.
The idea, I think, that battery recycling has boomed too soon or peaked too soon feels very short-sighted to me. It's important to point out here that the auto industry works on 5 to 7 year product cycles. The cars through 2025 are already locked down.
When we started, everyone thought that we were nuts, and we were, but we made the right call on the market. We didn't get carried away. We didn't have a lot of money to waste. We always had a focus on making the business work and make it profitable, and that's what we did.
While S&T is one of the pioneers of this space, like-minded companies like American Battery Technology are not far behind, developing new ways to domestically source metals.
We're building in anticipation. I don't know if it's boomed too soon. This is all new. It is an emerging space. We are all figuring out together how to do it. Some ideas will be winners, some ideas will be losers. Some businesses will be winners, some businesses will be losers. But progress is happening very rapidly. Iteration is happening very rapidly.